All right, this is the frog hop problem. So what is happening in this problem is we have a bunch of frogs hopping and they're racing. So we have the goal distance. That's how far they need to go. And they can only take so many hops, called max hops. We also have a method called hop distance, and it randomly generates an amount that your frog is going to hop. It could be positive or negative. So that's all the things that we have, and then we're going to simulate the race and see if the frog makes it there or not, and then we'll run simulations. So what happens in the first one is we have things that will make our frog stop. Our frog has reached goal or passed the goal, he'll stop and he's returned true. If the frog ever goes to a negative position, not a negative hop, but overall go past the starting in the wrong direction, then you're going to return false. And the last thing is he's only got so many hops that he's allowed to do. So this is our example. This says our goal distance is 24, and this is the number of max hops he's allowed to take. So when we called our function max hops, at first 5 came through. So that's our current distance. Then 7 comes through, so now he's at 12. He goes backwards 1, so now at 10. 8. And this is his 5th jump and his last one, and he made it. Now his second example, he makes it in 4 hops. In the next example, he makes it in 3 hops. On the 4th example, he jumps 4, then 2, so he's now at 6, but then he goes -8, so he got a final negative position. So he stops hopping there, even though he still has hops left. And then lastly, here, all of his hops are fairly small, so he didn't get to goal distance. Okay, so we have public Boolean simulate. So one of the first things that we need to keep track of is the position. And when he first starts, his position is going to be at 0. We're going to go until he's made his max hops. So for int hop equal to 0, hop less than max hops, h++. And the first thing he's going to do is hop. So position is going to accumulate the hop distance. Now at this point, we have to decide if he's done, meaning did he go less than 0? Did he go bigger than the hop distance? If he did either of those, then we're done. So if our position is greater than or equal to goal distance, then he made it. So we're going to return true. Else if our position is less than 0, we're going to return false because he's not going to make it. He went to a negative value, and once he hit a negative position, the game was over. Now, if both of these, he doesn't get a return statement from if or else if, that means he's going to hop again. And he's going to retest that. If we keep hopping all the way through that and we don't get killed out by either going backwards or passing the goal or finally getting to max hops, then he didn't make it. Okay, so the second part of this problem is we're going to run simulate several times and keep track of the proportion, the decimal equivalent, that the frog succeeded. So here this will be public double run simulation, and we're going to pass in how many times we're going to run the simulation. So for example, if I said I was going to run the simulation 4 times, maybe he passed it the first time, he passed it the second time, he didn't pass it the third time, and the fourth time. So I would expect him to be passing it 0.5% of the time. So we know how many times we're going to go through the simulation because that's num, but we need to figure out how many times are successful. So we need the variable count success. And originally that's going to be set equal to 0. Now we're going to go through the simulation as many times as we need to. So C will start at 0, C less than num, C++. We're counting how many times we're going to do this. Each time we're going to call the simulate function. Remember the simulate function that we just wrote returns true or false. So if it's true, that means that we go through and we're going to count as success. If it's not true, we do not count as success. And then lastly, you're going to return, and we have to make sure that we return a double. And remember, Java defaults integer divided by integer is integer division. So we're going to double count successes and then divide it by the num. Other things you could have done instead is you could have originally set this up to a double, and that would have been fine. I could have multiplied either of them by 1.0, but the most important thing is that AP is going to have you cast something like that. So how were the points done on this test? So there were 5 points in part A. So first thing, did you use hop distance? If you used hop distance anywhere in your program, you get a point. So that's for the hop distance. The next point comes from, did you do something to accumulate for max hops? Or did you check to goal distance? Did you return true or false for the position being less than 0? And is this loop with no error bounds? Part B is worth 4 points. The first one is you call simulate exactly the amount of times you should. We are going to initialize either what's it say? We gotta have the double here, that'll be 1 point. Returns the correct calculated value is 1 point. And then one of these having no error bounds on that will be the other point.